name is Kasmi, and I'm going to take you through a comparison of classification model performance on transportation datasets. This is the second part of the assignment. The first part has already been done, which in the first part of the assignment, we discussed about data mining, how data mining is important to transportation industry, or how data mining can help transportation industry in any way. So we stated two ways it can help transportation industry. We stated that it can help transportation industry to dictate fraud in car registration, and also to reduce pedestrian casualty. So, but in this part, we are going to take a step further in finding data mining benefits to transportation industry by using models, classification models, to check on the performance of transportation dataset. So this is the source of the dataset, and it consists of 2,535 records. This is the source in case if you want to make reference. We are going to use Weka as our tool to showcase how this performance is used. So first of all, this is our data set. But this first set of data set has already been reprocessed. The first part of reprocessing is that the casualty class, which is our target class, was a multi-class, and for us to achieve what we want to achieve, since our objective is to make it use classification, so we are going to make it a binary class. So for us to make it a binary class, we have to previously the values were 1, 2, and 3. 1 for driver, signifying that the casualty was a driver. 2, signifying the casualty was a passenger inside the car. 3, that the casualty was a pedestrian. But in this case, we have to make values of zeros to be either a passenger or a driver, while 1 signifies a pedestrian. So after the initial reprocessing, we got this value of the dataset. So our first part of this is to import our dataset into Weka. So our dataset is a CSV type of dataset. So after importation, this is what we got from our target class. Look at the class visualization showing the type values in the class. So this signifies that our target class is biased because zeros are very much larger than 1. So for us to get an unbiased value or result, we have to make these values to be uniform. So we have to again do another set of preprocessing. So another set of preprocessing that we have to do is to reduce record, or you can say it is record reduction. So we have to reduce record using Excel. So after reducing the record, you can see now that our target class are kind of uniform, each with 407 records. So here is all the preprocessing we did. Record reduction. Then, before we got to this, we already did 2 types of preprocessing, multi-class to binary class preprocessing, and record reduction. But before we go into data mining with Weka, we have to do some sort of another type of preprocessing, like feature selection. So in feature selection, we selected the features or attributes that are of benefit to us, like in respect to what we are trying to achieve, which is classification. We think that, or with this set of attributes, that the result will not be appropriate, so we decide to remove it. So now another set of preprocessing that we have to do is numeric to nominal. We have to do this because classification in Weka always use a nominal values rather than a numerical values. So that's why we have to do this, and we did this using Excel. So this is how we did it. But first of all, we have to install Power Query in Weka, so as to be able to do this. Now, after that, the values now will be, rather than 1, 0, and 1, it will now be P and N. So now, going into classification, this is just to explain what classification is and how, and naive place classifier. These are just the formulas, but we are not going to go through this. So after the preprocessing, then we're going to classifier to classify our data using naive Bayes, and we use cross validation with 10 folds to get these results of 91.5025% accurate. Here, you see that here our class was not too biased. It classified 350 or something like that. I cannot see it, but as A. It's classified here. I classified that A equals to B and B equals, and here it got that this amount it was classified as A and this amount was classified as B, meaning that our result was accurate, and the result of the accuracy is 91.50%, which is good enough. Then the next set is to use the next type of classifier that we use is KNIS level classifier. Using this classifier with 3 folds gave us a 94.5% accuracy. Then we further use a decision tree. Using decision tree, we got 93.84%. So here is the comparison of the results, where all of them we did attribute selection. So this one 95, 91.50, 94.58, and 93.84. So based on the accuracy results, K-level seems to be the best method for this. The reason why we say this is because based on the accuracy results. Thank you.